Hello viewers. So today we'll discuss the derivatives of composite functions. In my earlier video I have discussed about parametric differentiation. So let us discuss how to find the derivatives of composite functions, and the rule which is used to find the derivatives of composite functions is called chain rule. So let us take the definition. So suppose y is a function of t and t is a function of x. Clear? So y is equal to ft and t equal to gx. Now if we put the value of t equal to gx in y equal to ft, we get y equal to f of gx, and it shows that y is a composition of the functions f and g. So f of g is called the composition of functions. So here we have discussed the composition of two functions, that is f and g. F is a function of t and t is further a function of x. Now let us extend this idea to three functions. So here we have y equal to ft, and y is a function of t and t is a function of u and u is a function of x. Clear? So we can write y equal to f of gu. Clear? Now we can further write it as f of g of u. U is a function of h, so we can write it like this. Now by the notations of composition of two functions, we can write it as f o g o h of x. Clear? So here y becomes the composition of three functions, that is f, g and h. Now let us see how to find the derivative of composition of functions. Now let us take this function sine root x, and we have to find the derivative of sine root x. Now let fx is sine x and gx is root x. Obviously f of g of x is f of gx, and this becomes gx is square root of x, and f of x can be obtained by, now f of root x can be obtained by substituting root x in place of x. So it is sine of root x, which is our original function. Say this function is y, so it is equal to y. Clear? Thus we have obtained y as f o g of x. So here it means we have to find the derivative of y with respect to x. Clear? And for this we have to differentiate this composition of functions. Clear? So it means we have to find f o g prime of x. This dash or prime represents the differentiation of composition of f and g. So let us now write the rule by which we can differentiate this y with respect to x. So we write dy over dx equal to df. We can write it like this, df or dy over dt multiplied by dt over dx. Clear? So in case of composition of f and g, we find dy over dx equal to dy over dt first we differentiate y with respect to t, then we multiply it by this dt over dx, that is d is differentiated with respect to x. Clear? Now similarly in this case also we can find the derivative of y with respect to x by this rule. We can write dy over dt. First we differentiate y with respect to t, then we differentiate t with respect to u, and then we differentiate u with respect to x, and thus we get a chain of derivatives. Clear? So let us now come to this problem. We have to find the derivative of sine root x equal to y, and we have shown here how this function is a composition of f and g. Now here dy over dx, we have to differentiate this function with respect to x. This can be written as dy over dg. Clear? And then g is differentiated with respect to x. Clear? So what is dy over dg? Now this dy over dg can be written as y is sine of root x and root x is gx. So we write y as sine g. So sine g over dg multiplied dg over dx. So g is the function, gx is root x. Now the derivative of sine is cos. So this is cos g multiplied the derivative of root x is 1 over 2 root x. Now we again substitute the value of g as root x. So we get cos of root x multiplied 1 over 2 root x. So this is the required value of the derivative of sine root x with respect to x. Clear? Now let us will not do this problem like this. We can adopt a method to find the derivative of this. So let us illustrate that method. Now let us take one more example. Find the derivative of e raised to sine root x with respect to x. So let y equal to e raised to sine root x. Now let us further suppose u equal to sine root x. Clear? And say v is equal to root x. So this expression becomes y equal to e raised to u. Clear? And this expression u becomes sine of say v. So now we find dy over du, and dy over du is e raised to power u. Clear? This is 1. Then we find du over dv. Now this is cos of v. This is say equation 2. And then we find dv over dx, and the derivative of square root of x is 1 over 2 root x. So this is 3. Now we have to find the derivative of this function, which is y with respect to x. So we have to find this dy over dx. So this can be written as dy over du, du over dv, and dv over dx by chain rule. Clear? So we substitute the values. So we get here dy over du is e raised to u, du over dv is cos v, and dv over dx is 1 over root x. Clear? And again we resubstitute the values as u equal to sine of root x. So this is sine of root x. Cos of v implies cos of root x, and this is 1 over root x. So this is the required derivative of e raised to sine root x with respect to x. Now let us take one more example. Find the derivative of sine of cos x square with respect to x. So let us assume y equal to sine cos x square. Now suppose u is equal to cos of x square. Clear? And v is equal to x square. So first we assumed the whole function as y, then we assumed cos x square is equal to u, and then x square as v. Clear? Now let us find the derivative of y with respect to x. So by chain rule we can write dy over dx as dy over du, then du over dv, and then dv over dx. So we have made a chain like this. See, dy over du, then this du over dv, and this dv as dv over dx. So here this becomes sine of cos x square becomes sine of u. This becomes cos of v. Clear? Now let us find this dy over du. Now dy over du is simply cos of u, because the derivative of sine is cos, multiplied du over dv. Now du over dv is the derivative of cos v, and the derivative of cos v is minus of sine v, and dv over dx is 2x. So we again resubstitute the values. So we have cos of u is cos x square, multiplied minus of sine v is x square. Clear? And this is 2x. So this is the required derivative. Now viewers, let us take one more example. Find the derivative of log sine x square plus 1 with respect to x. So let us suppose y is equal to log of sine x square plus 1. Now let us further suppose u equal to sine of x square plus 1 and v as x square plus 1. So this function becomes y equal to log of u, and this becomes sine of x square plus 1. X square plus 1 is v, so this becomes sine of v, and this remains as such. So therefore dy over dx can be computed as dy over du, then du over dv, and then dv over dx. Clear? So what is dy over du? So dy over du is the derivative of log u with respect to u, and the derivative of log x is 1 over x. So this is 1 over u. So we write it here as 1 over u, and dy over dv, du over dv is the derivative of sine v with respect to v. So this is cos of v, and dv over dx is 2x, because the derivative of this constant is 0 and the derivative of x square is 2x. Now again we resubstitute the values. So we get 1 over u. U is sine of x square plus 1 multiplied cos of v. V is x square plus 1 multiplied 2x. Now cos x square plus 1 over sine x square plus 1 is cot of x square plus 1 and multiplied 2x, and we can write it here 2x. So this is the required derivative. Now let us take one more example. The derivative of e raised to sine inverse of square root of x with respect to x. So we assume y equal to e raised to sine inverse of root x. So let u equal to sine inverse root x and v is square root of x. We assume this as u and then this as v. Clear? So this becomes e raised to u and this becomes sine inverse of root x is v. So this is v. So therefore the derivative dy over dx can be written as dy over du, then du over dv, and then dv over dx. Clear? So what is the derivative of this dy over du? We have to simply differentiate e raised to u with respect to u, and it is the function itself. So we have e raised to u multiplied du over dv. Now here we have to find the derivative of u with respect to v, and here we have the sine inverse function. So this is 1 over square root of 1 minus v square. Clear? So we substitute here 1 minus v square, and dv over dx is 1 over root x, and we substitute it here. Clear? Now again resubstitute the values. So u is sine inverse root x. So here we have sine of root x 1 over square root of 1 minus v square, and v square is, from here v square is x. So we write 1 minus x and multiplied 1 over 2 root x. So this is the required derivative. Clear? Let us take one more example. We have to find the derivative of tan of log of sine of e raised to x with respect to x. So let us assume this function as y. Now let u is equal to log of sine of e raised to x. Clear? Let v is equal to sine of e raised to x. Clear? And say w is e raised to x. So therefore this function becomes y is equal to tan of log of sine e raised to x. So sine e raised to x is v. So we have it tan of log v, and which can further be written as tan of log of v. This becomes log of v. Clear? And this becomes sine of w. Clear? So this function becomes log of v is u. So it becomes y equal to tan u. Clear? So now by chain rule, the derivative dy over dx can be written as, see, this can be written as dy over du, then du over this is du, so this is du over dv, then this is dv over dw, and then this is dw over dx. Clear? So dy over du, that is the derivative of this function, is the derivative of tan x is secant square x. So this becomes secant square of u. Clear? Du over dv, the derivative of log x is 1 over x. So this is 1 over v. dv over dw, so the derivative of v with respect to w is cos of w. And dw by dx is the derivative of e raised to x is e raised to x. So we have this expression. Now resubstituting, we get secant square of u. U is log of sine of e raised to x. Clear? Multiplied 1 over v. V is 1 over sine e raised to x. Clear? Then cos of w is cos of e raised to x. Clear? And then we have e raised to x. Now we can further simplify it. Cos e raised to x over sine e raised to x can be written as cot x, and this is e raised to x. So we can write sec square log of sine e raised to x multiplied cot of e raised to x and then multiplied e raised to x. So this is the required value of dy over dx. Clear? Now let us find the derivative of square root of 10x with respect to x by using chain rule. So let y is equal to root of 10x. Now further assume u equal to 10x. Clear? So u equal to 10x, if we substitute here, we get y is equal to square root of u. So now by chain rule, we can write dy over dx can be written as dy over du multiplied du over dx. So what is the derivative of y with respect to u? We can write it as u raised to half. So dy over du is 1 over 2 times square root of u. Here we have applied the formula d over dx of x raised to n is nx n minus 1. Clear? So dy over du is 1 over 2 root u multiplied du over dx, the derivative of 10x is secant square x. Clear? So again we substitute the value of u as 10x. So we have secant square x, this secant square x over 2 multiplied square root of u means square root of 10x. So this is the required derivative of y with respect to x. Let us take one more example. Here we have to find the derivative of y with respect to x, and y is given as square root of e raised to square root of x. So here let u is equal to e raised to x root x, sorry, and v is equal to square root of x. So therefore this expression becomes because this becomes e raised to root x is u, so this becomes y is equal to square root of u, and this relation becomes for example dy over dx can be written as, so by chain rule dy over dx can be written as dy over du multiplied du over dv multiplied dv over dx. So y becomes square root of u. So this implies dy over du is 1 over 2 times of root u. Clear? And u becomes e raised to power v because square root of x is v. So therefore du over dv is e raised to v, and this dv over dx is 1 over 2 times of root x. Now we substitute the values here. So we get dy over du is 1 over 2 root u multiplied du over dv is e raised to v, and dv over dx is 1 over 2 root x. Clear? So we can write and we can simplify it. 1 over this is 4 square root of ux, and here we have e raised to v. So we resubstitute the values and we get u was e raised to root x. So this is x multiplied e raised to root x multiplied e raised to root x. Clear? So this is the required value of the derivative of y with respect to x. Let us take one more example. Here we have the function y is equal to 2x square plus 3x minus 9 raised to power 10, and we have to find the derivative dy over dx. So let u is 2x square plus 3x minus 9. Clear? So this function y becomes u raised to power 10. Clear? Now by chain rule we can write dy over dx as dy over du multiplied du over dx. Clear? So what is dy over du? Dy over du is, we apply the formula for x raised to n. So this is 10 u 10 minus 1. So this becomes 10 u raised to power 9. So here we have 10 u raised to 9 multiplied du over dx. Now here we have du over dx. So du over dx is equal to the derivative of x square is 2x. So 2x multiplied 2 is 4x, and the derivative of x is 1, so we are left with only 3, and the derivative of constant function is 0, so the derivative of 9 is 0. So we have du over dx as 4x plus 3. So we write it here. For this du over dx, 4x plus 3. Now again we resubstitute. We get 10 multiplied u was 2x square plus 3x minus 9 raised to power 9 multiplied 4x plus 3. Clear? So this is the required value of this dy over dx. Now let us take one more example. Here we have to find the derivative of y with respect to x for y equal to 1 over 2x square plus 3x minus 10 raised to power 10. Clear? Now here again we'll assume u as 2x square plus 3x minus 9. So this expression becomes u raised to power 10, which can be written as u raised to minus 10. Clear? Now, so therefore by chain rule we have to find this derivative dy over dx. So therefore dy over dx can be written as dy over du multiplied du over dx. So what is the value of dy over du? Here dy over du is minus 10 u raised to power minus 10 minus 1. So this is minus 10 u raised to power minus 11. So this is minus 10 u raised to power 11. Clear? So we substitute here minus 10 u raised to power 11 multiplied du over dx. From here the value of du over dx is 4x, as we have seen in previous example. This is 4x plus 3. So we substitute here du over dx as 4x plus 3. Okay, so we finally write minus 10 multiplied 4x plus 3 divided by, we substitute the value of u as this. So this is 2x square plus 3x minus 9 raised to 11. So this is the required derivative. Clear?